I went from making 60 grand a year to 450 grand per year as a data engineer in less than 5 years' time. I started my career at Amazon. I went to Lyft, and I was able to work with a few startups in between. And every single time I jumped to a different company, I made an extra 20, 40, 60% more in my compensation as a data engineer. And the thing that most people get wrong is that they think they just need to learn a bunch of tools. What they don't realize is learning projects so they can see how those tools operate is a way better system, because then you can talk about these projects and the real business impact that these tools have when you actually get on an interview, and also when you present your resume and are applying to a bunch of jobs to hiring managers and to recruiters. So in this next video, we have created a project for you to enjoy. And if you do, then please subscribe, like, click on the link below, write in the comments so that you can suggest any more videos that you want us to create, because our goal is to create as many videos as we can for you for free so that we can upload it to YouTube and so that you can enjoy. Other than that, enjoy the project and enjoy the free video. Cheers.
Set up a recording for today. All right, so today is going to be RAG with Langchain-Llama, Nomic Text Embed, and let's say Llama 3.1 as well. All right, so that's the goal. And of course, ChromaDB as well. Cool. So now we have this. Let's now take a look. So what we're going to do is I'm just going to close a few tabs here. And let's now go into source, and we'll create a new folder for June 30th. Let's go ahead and do that. All right, so in here, the first thing we need to do is let's make sure that you have the Llama embeddings first, right? So what we're going to do is we're going to check the exact name of the model that you need to make this work. So I'm going to use Llama list in my terminal. And the specific one you want is this one right here, Nomic Embed Text. This is a very good embedding model. It actually ranks really well on a leaderboard called MTEB. I believe I mentioned what MTEB is in the past, but it stands for the Massive Text Embedding Benchmark. So if you find any models that are in like the top 20 in that benchmark, then it's definitely worth using. And what's really cool is models like Nomic Embed Text, they actually are up there in the top 20, along with some other open source embedding models that came out just a few months ago. So it's definitely a good idea to see like which ones are available on Llama, and then you should definitely try them out. That's a very cool use of embedding models, because you don't have to pay for your embeddings, right? You don't have to use like OpenAI embeddings like just to get good performance. All right, so that's like one really cool thing. And so we're going to just quickly revise here, like how to get the embeddings, right, using Llama. So we're going to say from Langchain Llama, you want to import Llama embeddings, just like that. And then from here, you want to instantiate your embedding model. So let's say that your embedding model is Nomic Embed Text. So you could say Llama embeddings. The model is going to be Nomic Embed Text. And then from here, now let's say that you have some sort of user input. So maybe your user input is a string that says, did you know that Aquafina is a bottled water vendor? So maybe something like that. And then what we'll say is that we can use a method that belongs to our embedding model variable here, which is to say embed documents or embed query. So let's say if you use embed query, then the text is going to be user input like this. And then we can say over here that we can now embed the text. And let's say you call this as a result. Then down here, you want to print the result. Right, so let's say you actually do this. It will use that model and it will give you the embedding associated with that text. Now, one thing you'll notice is that you might be wondering, like, how many dimensions does this have? So you can find that out in a couple ways. You can easily just take like a length of it, and that should pretty much tell you like the dimension of this embedding model. But another way you can also do it is you could just use Olama list, and it should actually give you some details. So let's see. So it actually says over here that it's using the latest one. So yeah, so it actually doesn't give you all the metadata. So you would probably have to search it on Olama directly. But yeah, if you go to Olama and you search for Nomic embed text, it should tell you some details. So you can see the context is 2000, and tells you like the size and memory, and you can see even more details about it here. It tells you that it's actually better than OpenAI's like Auto 2 and Embedding 3 Small. Embedding 3 Small is actually still used today by a lot of enterprises. So the fact that this is better than that is helping you save a lot of money. Um, but yeah, so yeah, so you can get some details from here. So it looks like it's really just like 2000. I think that's really the key. Um, so yeah, so that's basically the model that we're using. And now that we know how to get embeddings, you can also get embeddings for a whole bunch of documents as well. So one of the ways that we can actually leverage this is, let's say that you have some text that you're trying to break into smaller text. So the term that we use for that is called chunking. So I'm going to show you how to do that today using something called a document loader. And then from that document loader, we want to take each of the different smaller pieces of text, which we call as chunks, and you want to basically embed them. And you want to put those embeddings inside of a vector database. Like that's really the idea. So we're going to use Chroma as our vector database. But before we go into Chroma, let's talk about the chunking aspect. All right. And then one more thing I would also show you is how do you embed multiple documents? So you can actually do that as well by saying embedding model dot, and then you just say embed documents. And on the inside, it's going to ask you for a list of strings. So if you represent your list of strings, meaning your different chunks within a list, you can easily get embeddings for all of them. So that's like a really cool feature with Langchain Olama. All right, so now that we have all that, let's now move on to creating chunks. All right, so now what we're going to do is we're going to create text chunks. So for this one, we need to use another package in LangChain's ecosystem, which is called LangChain Community. So we're going to say from LangChain Community, we can now go to document loaders. And then from here, we want to add something called a text loader. So now what's interesting about this text loader is it can take in a path to a text file or even a directory of text files. But actually, you should use directory loader instead of text loader in that case. But in this one, let's say you're just doing it from a single document. Then you can use text loader. So let's say you have like a loader object where you would say loader is a text loader, just like this. And on the inside, it's actually going to ask you for a path to your file. So just to deal with paths and stuff, we're going to use OS, and I'll use get current working directory here. So what I'm going to do is I'm going to find a text file, which is used as a pretty popular example for this kind of stuff. We're going to look at one that comes from a very old State of the Union address. There's actually it's actually very popular in a lot of examples. So let me just quickly find that for you. Let's see, I think I just found it. Yeah, I just need to download it real quick. So let me just download the file. Okay, so I got it. All right, so now what I'm going to do is I'm just going to create a folder here. Actually, I can just put it in the same one, actually. I'll just put it in here. So what I'll do is I'll just go here, downloads, yeah, and then I'll just put that over here. And I'm just going to rename this to State of the Union. Yeah, and then I'll also add like a S3 URL to this, so that way you can easily access it. But for now, I'm just going to put text in here so we don't commit it. Cool. So now that we have that, we want to use this file to be able to create different chunks out of our text loader. So we're going to copy this relatively, and we're going to create a path to the file. So our file path is going to be getCWD, and you just want to take that relative copied text here. And then inside the text loader, you can instantiate it with the file path. So you can say the file path needs to be this file path here. So now after getting this loader, then let's see what we can do with it. So if you go to the loader, you can see that there's a couple of different things here where it says things like lazy load or load and split. There's a lot of stuff we can actually do with it. So if you do load, then it actually gives you a list of documents. So let's actually see what happens if you do that. So let's say you call this as results, and why don't we actually see the length first? Like how many do we actually have when you do this? So if you go ahead and run this, you'll see that we end up getting one. So what this text loader is doing right now is it understood that we have one text file, and now it treats that as a singular document. So now let's say if you had, let's say, a directory of documents where let's say you had like 5 or 6 different documents, you can change this to directory loader, and then you can pass the folder path of where all your files are, and it will treat each of those files as red strings into different elements in the list. So if you had like 6 files, you would have a length of 6, right? So that's how that would work. So now one of the things that we have to do is we have to take this document and we have to turn it into individual pieces. So the way we're going to do that is called text splitting. So that's what we're going to do next. But one thing I just wanted to show you real quick about how this works is when you actually use the load here, you'll see it says that it gives you a list of documents. So this is a very important distinction because what does a document really mean in the context of LangChain? So a document is an object that LangChain uses where it's not really just the text. It could also contain some metadata and a couple of other aspects of this type of work. So what we want to do is we particularly want to get the string of the text. So how do we get that string text from the document? So to do that, we have to inspect the document a little bit. So the way we're going to do that is let's actually get the document. So we'll say the document is just results and just index and get the first element of that list. So now if you print the type of document, you'll see that it actually tells you that it's a LangChain core documents-based document. So that's the actual object. So now from here, what you want to do is you want to take the string out of it. So how are you going to do that? You can actually get its attributes, right? So what are the attributes that are associated with this? So we can get the attributes of the document. So we can say document, and then over here, let's say if you look at these dunder things, so you have things like, class variables, and you also have get attribute, right, and all this other stuff, right? So that's one thing. One thing that also helps is if you do dictionary like this, then you can actually get all of the attributes and their values technically as like key value pairs, right? So that's also another pretty cool thing about this. So let's say if you call this as like a new result, and if you were to print that, then let's say you get the keys that are associated with this. And if you go ahead and run it, then it's going to say that you have access to these ID, metadata, page content, and type. So from here, these are the different attributes that you have access to. So the attribute that we want to actually look at is this one, page content. So if you weren't using this dictionary thing to get all the attributes, you can actually get it directly from here by saying that the document is the document, but then you want to say dot page content. That's going to be your attribute. So then when you do this, you're actually going to end up getting a string. And so if you print that, then you're actually going to see the string. And then this one over here, I'm going to put above it, right? Just so then you know that it won't screw it up. All right, cool. So now if you try to run this, you'll see that it actually does give you the whole text now when you do that. So that's basically the page content attribute that belongs to the document class in LangChain. All right, so now that we have some understanding, right, of how to get the text from a document loader, the next thing we want to do is we want to split the text. So to split the text, we're actually going to use another thing from LangChain community, which is called text splitters. So I'm going to say from LangChain community, we can say document, let's see, text, or let's see, document, it should be text splitters. You know what? maybe it's actually Langchain core, actually. Langchain core, splitters. Okay, you know what? I am forgetting a little bit. So give me 1 sec. I'll tell you what it is in just a sec. It's yeah, it's supposed to be under interesting. So this is something new. I did not know that they did this recently, but they actually created their own package specifically for text splitters. In the past, it actually would come from either LangChain Core or LangChain Community, but it looks like that the new one now belongs to its own package. So let me show you how to get that. So what you would do is you want to go here and say requirements.txt, and let's just mention what are the ones that you need. So LangChain for sure, LangChain Community, you want LangChain Olama, you want LangChain Chroma as well for ChromaDB. And then we also want the new one, which is LangChain Text Splitters. So these are the ones that you actually want to use. All right, so now from here, if you install this, so let's go ahead and do that. So this is Olama DEA environment. So I'm just going to deactivate this. And what I'm going to do is I'm just going to go over here, open that in here. I'm just going to verify that I'm in that environment. So I'm just going to do conda deactivate again, and then conda activate Olama DEA environment. And now I'm just going to do a pip install. All right, so now it's getting all the dependencies for things like LangChain Chroma, and also for LangChain text splitters. There we go. So now, when you work with LangChain text splitters, it's going to help you to transform your large string into smaller strings. So we're going to try that out by saying from LangChain text splitters. We're going to look at two different kinds of splitters. The first one is going to be a character text splitter, and the second one is going to be called a recursive text splitter. So let's start with the character text splitter. So when you have this character text splitter, what we're going to end up doing on the bottom here is that now that you have the page content that's associated with your document, we're now going to try to see if we can invoke a splitter. So to do that is we're going to say splitter is the text, the character text splitter, just like this. And now it mentions like, how do you want to like separate like the characters? So in this one, it actually looks at new line statements. You can also use some regular expression to be able to split things too. So it has a couple of options here. But let's say if you keep it by default, then what you want to do is you can use a method from here, which is called split documents or split text. So you can use either one. So let's say since we already got the text from the document, we can actually say split text. And then from here, it's going to ask you for what that text is. So we can say over here that the text is going to be our document. And let's say we call this as our split result. So now when you actually run this, it gives you a list of strings, right? So now if you try to, let's say, get the length of this, right? So let's say you get the length of split result. Let's see, what do we actually get when you do that? So if you run it, you'll see it gives you 11. It gives you 11 different like chunks that are associated with your original text. So why don't we see a preview of maybe the first one? So let's look at the first chunk. So for the first chunk, you can say you have the split result, and let's say you get the first one, and let's say you just decide to print that out. So if you do that, let's see how much of that original text is captured inside the character text splitter. So if you do that, you'll see that, let's see, where's the 11? So actually I have an idea. Let's do a little utility here. We're just going to create a custom utility that allows you to separate lines. So we'll call it as like a format utility. So we'll say def line separator. And we're going to put symbol, which is a string. We're going to say it's like a hyphen. We're going to say n is an integer. Let's set that to 50. And the idea is that it doesn't really return anything, but the idea is that you're just printing the symbol multiplied by n. So now you can use this as a quick way to separate different print results. So over here, we just go here and then we can say line separator, and we can probably do that over here too. All right, so now if you run this again, you can easily find out where things start and end. So now if you go back up here, you can see this is where it starts. So right after this 11, so basically from Madam Speaker, it went from Madam Speaker all the way to what you see on the bottom. So all of this was split automatically as one of our 11 chunks that's coming from that character text splitter. So that's like one of the cool um, features that you get with LangChain, right? So it actually has like really cool methods like this where you can easily split out text. So character text splitter is pretty decent because it allows you to think about things from regular expressions, or you can have separators, right, to easily split things out. So because the split was based on having two new line characters side by side, that's the reason why it was able to identify 11 of those. So that's why it was able to easily split it. But now you can always change it to other things too. Like for example, what if you just wanted every single new line? Then you could just do a single line, right? So you could change this to the separator to be just a \n. So if you run it again, now you should expect way more than 11. So now if you do this, we can see, or actually that's interesting. So even with just a single new line, it actually still gives you 11. So that's pretty interesting actually. I was expecting that it would give you more, but it looks like anytime you look at the output, it actually is based on having more than one new line, or together basically, or even just a single one. It seems like it would be 11. So that's interesting actually, that it does that. But of course, there are other ways that this could be done. Like, what if you want to base it off of periods, right? You could do that. So if you change it off of periods, then you're kind of getting the indication that it's like doing sentence-based separation. It's not exact, but it's definitely on the right track, right? So if you do that, then let's see. So if you do that, you get a total of, okay, wait, something is wrong here. It should not just,
Hey, real quick. If you are looking to land a higher paying data role, then there will be a link in the description or in the comment section for you to fill out a form and then book a call with my team who has already helped over 2,000 people get a higher paying data role. And we hope that you are the next person that we help. And so all you have to do is click on the link below. And if you don't want to help, no worries at all. Keep watching the video, keep enjoying it. And yeah, let's go back to the video now.
just be 11. Because yeah, it should have split this from
Maybe
this one.
period is not, you don't have any actual periods that are not by themselves.
Yeah, that's a good point. Yeah, so it's probably combined with like the new lines and all that. Yeah, so that's a good point. So maybe if we did something like this, maybe, then let's see if that picks up anything. Hmm.
Does seem like it looks a little different, but like all the new lines went away.
Right. Yeah, so now it shows one here, but we would expect it to be more than that down here.
Not just one. That's hilarious.
Yeah, that's
But
interesting.
obviously takes trial and error.
Yeah, so that's the thing. You'd have to play around with the separators, like to figure out like what makes sense based on the data. You can always like print out like the string, or you can just like put it in a list perhaps, and then from there you can find out like what's actually happening at the end of the line, and that should be able to help you to get more. But this is just one of the kinds of splitters you have. I mean, you could always have other ones too. Like in fact, one that I feel like is more commonly used is one that's called recursive character text splitter. This one is actually a lot better. So let's actually try to use that one. All right, just to show you an example. So if you want to use like the recursive character text splitter, then just like we did with the other one, you can create a recursive splitter object. And then in here, now you can mention a list of separators. You could tell it to keep a separator, meaning like at the start or end. Uh, and then let's see, or actually that's a Boolean. So you can set that to be like true or false. You can mention over here, there's also the values of like start or end for the keep separator besides just being a Boolean. And you can also mention the regex there too. But let's say if you just keep it as is, and if you try to maybe see the difference between this and character text splitter, let's see like what it does, right? So if you use this, let's do split result is recursive splitter dot split text. And let's say that your text is the document. And then from here, let's say you get the length of split results. Let's also add like a line separator over here. And then let's also add it again over here. And let's take a look at maybe the first one. All right, so if you do that, let's see what do we get? Do we see any differences? Oops, there we go. Okay, so if we go up here, all right, so it looks like we're getting 11 here too. And let's see, maybe one thing that might help actually to figure this out is let's look at the length of the characters that come from this one. And let's do the same thing with the one that's over here too. So we can see like, do they actually have the same number of characters or do they change? Right, so if you do that, so you can see that one of them has 3849 and the other one has 38539. So that's pretty interesting, right? But of course, this one is actually because it's the whole thing, right? So if we change that separator, let's see if it gives you the same or not. So if we just remove what it was and just keep the original, now let's actually see what happens. Like, does it actually give you the same or is it different? It looks like it's the same. So it looks like when we are working with just the default separators, you're getting the same number of characters for each chunk, at least for the way it currently seems to be working. But there are a few things we could do to adjust it. So one of the things we can actually do here is we can add some keywords. So let's say, for example, for a character text splitter, we can add a keyword which is called chunk size. So you can change the chunk size to, let's say, something like 100. So let's say if you change it to 100, then instead of it being 3849, you're now going to get chunks that have a maximum number of characters of 100. So that's one thing you could do. And you can also set another property, which is called chunk overlap. So what chunk overlap does is chunk overlap allows you to see, will some of the context from your previous chunk also seep into the next chunk? So that's what the overlap does. If you set it to 0, then you assume that there's not going to be any overlap. But you can also set a certain number of characters to overlap in case you wanted to. So if you do that, maybe you can say something like 20. So this could be like one way to control for your chunks. And you can use the same parameters with the recursive one as well. So let's say we actually do that. Let's see if there's a difference after adding that customization. Right? So now if we try to do that, so we can see that we're creating chunks of size. Okay, so we're creating chunks that are larger than the specified 100. But one thing that's interesting here is if you look at some of the values that we have, let's see. So you have all these values, and then it created the chunks. And then we can see we have 336, 162. So let's actually just add some more context just so we know what it is. So we can say that this is like the the chunk size. And let's also do that one over here. So this is how many chunks you have, right? So you have 570 chunks here. And then if you look at the one above, you have 336 chunks. So as you can see, when you add the customization, that's when these algorithms start to behave a little bit differently. Because you can see that the character one, it just takes it pretty much the way that you described it. Because you know that there's like approximately 3,700 characters in the text. So then you asked for 10 chunks. So it's trying to do its best to evenly separate it. It knows that some of them can't be exactly 100. So it tries to go a little bit more, right? Just to be able to kind of distribute it as close as you can to as many that you need to be able to get for each one like 100 characters, right? So that's why you'll see that it takes that literally and creates like 336. But what's interesting about the one with the recursive is the recursive gave you a lot more, right? The recursive gave you a bunch more chunks. And so the reason for that is because the recursive text splitter is actually trying to not only just get you just a basic division of like all your strings, but it's also trying to like preserve some context by looking at your previous chunks and trying to see like how can it re-chunk it to be able to preserve as much context as possible in each chunk. So sometimes the best way to do that is to create smaller chunks where you don't lose the context. And so that's what it uses as a guiding mechanism to create more chunks than the one that doesn't have as much. So so that's where the 570 is really coming from instead of 336, where even though you want chunks to be 100, a lot of times that size of 100 is also adding in a lot of more context. So you could actually short it down into, let's say, maybe like 50 and 50, and you can create like two chunks for an original one chunk where whatever is in those 50 characters is going to be relevant context, like to what's supposed to be split from the text. So that's like one advantage of using the recursive text splitter, like over the character text splitter. But the character text splitter is good if you want that even distribution of your chunk sizes. So character text splitter is pretty good for that. So these are some pretty important considerations because whenever you're working with the RAG system, at the end of the day, the text that you're splitting, all of this split text is actually what your RAG system is going to be using to compare against what you're asking. And so one of the exercises that we're going to do is when we embed all of these chunks and we put them into something like an embedding model, right? Like Nomic Text Embed, we actually want the vector database to store the embeddings of these chunks. And the goal is that if you ask a question, let's say the question that you ask is, what did the president say about Ketanji Jackson? Let's say like that happens to be the question. Then you want to be able to do an embedding search where the embedding of that question is now going to be compared with the embeddings of your chunks. So if you use that into your consideration for your RAG system, then one of the important caveats that you have to keep in mind is that your chunks actually matter a lot. Because what if your chunks happen to have information in which some things are missing? Or what if it doesn't give you a complete sentence? So if you have chunks that miss context, then the embedding similarity search is going to show that. It's going to reflect that, right? Because you would expect models like Nomic Text Embed to be able to give you the semantically relevant results, right? When it comes to the search. So if you're not able to capture that semantic meaning properly, then the search can fall short and you might end up getting context that you don't want. And so that missed context is then what gets fed to an LLM to be able to give you the final answer when you have the RAG system. So that's the reason why it's really important to think about the way that you chunk your text.
What happens if your result is in multiple chunks?
Yeah, so that's what I'm saying, right? Like this also leads to that situation too, where if your result is in multiple chunks, so let's actually think of an example of that actually, right? I mean, because there are a couple of possibilities there, right? Where let's say in the example about what the president said about Kennedy Jackson, for example. So let's say that there's a whole one pager that's related to Kennedy Jackson. So maybe there's like one portion of the text that belongs in one chunk, and maybe there's like another portion of something related to Kenji Jackson, maybe in a second chunk. Then what usually happens in that situation is who said that you only have to get one chunk as an output? You can actually mention your top N search results. Remember what we did when we did the semantic search before, right? With like word to vec and things like that. We always mentioned you can get top N results or top K results, right? Where we said, give me the top 3 results or give me the top 5 results. So the goal is when you have your result in multiple chunks, you want to set a value of K to be able to say, how many results should I be expecting that could potentially have my answer? So maybe you set the threshold to maybe 5. Like you don't expect more than 5 chunks to have your answer. So then when you set the K to 5, it will actually give you those 5 chunks as an output. So that's like one way you can retrieve the context from multiple chunks. So that's one way to look at it.
Cool,
But
thanks.
then there's also another aspect where maybe you're expecting it to only return one chunk. And so usually what that implies is the algorithm that you're using for the embedding, maybe the algorithm itself is not good enough for being able to get that semantic search. That could be one possibility. The other possibility is that the question that's being asked is not showing enough semantic capabilities to differentiate from other chunks. So a lot of times, even the question or the query needs to be adjusted. And so one of the techniques that you'll hear about in RAG is this idea called query expansion, which is how do you add even more context to your query? So then you'll be able to make it easily match to only one chunk as opposed to others. So these are all the different things that can go wrong in a RAG system. And there's people that are always trying new experiments, right, to be able to see what works. And in the AI course, you're going to learn about quite a few ways to tackle this. All right. So one of them is something called HIDE, which is like hypothetical document embeddings. There's also different ways to do query expansion. You can also use something called a re-ranker. And there's also like different ways of doing the semantic similarity, where instead of doing like a cosine similarity, you can use something called MRR, which is like minimally redundant but maximally relevant, or MR, right? That's what it's called. Yeah. So these are like the different things you could do, like to, and you have to try all these experiments to see which one is giving you the best results. So yeah, there's a lot of things that go into RAG, right? I mean, it's a whole it's an art and a science, right? There's a lot that's going into it. But this is like kind of giving you the basic primers to see like all the areas where it could go wrong, right? So that's what I wanted to demonstrate. So now imagine if you're doing this for things like video and audio, right? It becomes even more complex, right? Because now you have to have ways of embedding that kind of data. And so what if you have like missing context like from those kind of data points, right? Then it becomes even more frustrating, right? So there's a lot of places where it could go wrong.
Makes sense.
Hey, Rishoff.
Yeah.
Uh, yeah, I'm sorry, a little bit lost. Why we need to split?
Yeah, good question.
Yeah,
So
and
the
also one other thing. We also have a split function, right, in Python.
uh-huh.
So if you could talk about both things, please.
Sure, yeah, absolutely. So you could use the split function in Python. That's totally fine. But the only thing about the split function in Python is that one is going to limit you to what you can do with this one here, which is the character text splitter, where you're mentioning what the separator is. But you see, that's where the split function ends, right? It ends with just the ability to separate based on some sort of a delimiter. But then what if you also want to adjust for how many characters should you have in one chunk? Or what if you want to say that some characters from a previous chunk could go into the next one? So those things you wouldn't be able to do with the split function in Python, right? You're limited to only just being able to separate things. So if you know that you're trying to separate by sentences, then yeah, you can probably add a regex or some period, right, as an approximation for different sentences. Or you can even use like the sent tokenized from NLTK, right? A lot of different ways to tackle that. But the thing is that you're limited to just that one function, right? Which is the ability to split by a delimiter. But then if you need more flexibility, then you need to use something like this where you have all these things. Now, of course, you could add your own logic, right? Where you could create functions that build on top of the split function, right? To be able to add chunk size and chunk overlap. But again, you're limiting it to just the ability to split by the characters. But then when you go into the recursive text splitter, the recursive text splitter is more complicated because it's actually using recursion for every split that it does, and it tries to figure out how to give you the final chunk in such a way where it will always preserve the context of the actual text that you're splitting. So that's the reason why using these more sophisticated ones give you more functionality. And then the other question you asked is, why do you have to split? Which is a fantastic question. So I'll tell you why we have to split. So when you look at embedding models have a finite context as to how much can you put in at one time to be able to get an embedding. So when you look at the nomic text embed, one of the things that we saw is that its context was 2000. So one of the ways that we can interpret that is that the overall size of your string should not exceed 2000. Or maybe after tokenization, it should not exceed 2000, right? So that's like another way of interpreting it. So now when you have a really large text, right, that goes beyond that character size, it will fail to create an embedding, right? Because the idea of creating these split chunks and everything is so then you have the data in a finite size, which is compatible to receive an embedding. Because these embeddings are then going to be stored inside of a vector database so we can perform search, right? So that's essentially why we have to split it.
Nice. Thank you. Appreciate it.
Yeah, of course. All right. So now that we have all of that answered, the next thing we're going to do is we're going to take a look at how do we now bring all of these split results into a vector database. In particular, we're going to work with ChromaDB. So to do that, we're actually going to add a little bit more to this. So I'm going to create a new file, which is called load embeddings into vector, or let's say vector DB. All right, so for this one here, we're going to import a couple things. We're going to import Chroma. So we're going to say from ChromaDB, we want to get something that just says, let's see. Okay, actually, did they change this one too a little bit? No. No, it should be like this, but then instead of HTTP client, I just want the client. Yes, that's what I want. I just want the client. All right, and then when you look at the client, you can actually use the default settings, like just keep things the way they are. And you could just set it as client is like this. So this is basically like a ChromaDB local client. So this is going to create a location on your machine where it persists the data. It's all file based. Now, there are ways to move this to, let's say, a network based client. So you can change this to something like HTTP client. And that would allow you to work with this using like a server. But right now, we don't have a ChromaDB server. So we're just going to use the one that persists locally today. And then in the next session, I'm going to show all of you how to create that network-based server. All right, so now that we have ChromaDB locally like this, one of the things that we also want to leverage is a package that comes from Langchain, which is called Langchain Chroma. So we're going to say from Langchain Chroma, we're going to import the Chroma object like this. And we can use the Chroma object to actually help us with embedding all of our split results. So, and put that into that vector database. So we're going to do all of that. And then another thing we're also going to do is we're going to use, let's see, let's get Langchain Olama, and let's get the Olama embeddings as well. So basically we want to mention to Chroma that we're going to be using Olama embeddings for getting all the context, right? That's what we want to use. So now that we have our client, let's also mention that we're getting the Langchain Chroma object. So for this one, let's call it as Langchain. Actually, instead of doing that, because it's already a package name, we're going to call this as like a Chroma object. And we're going to say Chroma. And on here, it's going to ask you for some stuff. So let's say that we keep the collection the way it is just for now. And let's say where it says the embedding function, we're going to mention that the embedding function is going to be Olama embeddings. So we're going to say for the embedding function, we're going to set that to Olama embeddings, where you specify that the model happens to be nomic embed text. All right, so that's what we want to do there. So now after creating this Chroma object, then the next thing that we want to do is let's take a look at some of its methods. So if you look at what it says here, it says that you can add text, and you might be wondering, what does the extra A mean? Does anyone know what the extra A means before things like add documents or add text? Anyone know?
No.
It's okay if you don't. It actually comes down to a software engineering principle. So you could look at workflows and programming in a synchronous manner or a sequential manner, but there's also another way you could look at programs. You could see programs running asynchronously, right? So you could have like different parts of a process running in parallel, and you don't have to wait for everything to finish before continuing the rest of the process, right? So anytime we define that kind of workflow, right, in programming, we call that as like an asynchronous workflow, right? And so that first A that you see there, that stands for asynchronous. So this means we can add texts asynchronously, or we can add documents asynchronously. So that's what that implies. Fun trivia today. All right, so what we're going to do for Chroma here is we're just going to add the text. All right, so we're going to add the text here.
So Rishabh, the
Yes.
asynchronous, you want to use it when you're dealing with a lot of data, or
So you can use it in multiple ways. So yeah, whenever you're dealing with lots of data, you do get a lot of performance gains by being able to create coroutines of the various aspects of the process. So yeah, so if you do set it up asynchronously, then it will definitely be more performant. But
okay,
typically, whenever you work with asynchronous things over a network, you need to have the server having the support to be asynchronous. So that's why one of the things you noticed, right, is when we imported the client, there were a couple of other options, right? There was HTTP client, but there's also async HTTP client. This is also important because a lot of times, like when you set up Chroma, even from a server perspective, at a network level, not everything is guaranteed to be asynchronous. It actually needs to follow a certain standard. And so the network standard for anything that's asynchronous is called ASGI. So if you've ever built like APIs before, you might have heard of things like WSGI based APIs and ASGI APIs. So WSGI would be things like Flask. Like if you've worked with Flask before, that's considered as a WSGI standard for making APIs, where it doesn't allow you to do things asynchronously, but you can still serve objects and everything like over a network, right? Like especially things like JSON and stuff like that. But when you work with ASGI, you can actually create coroutines as part of your endpoints, right? Where you can say that multiple things can happen in parallel without waiting for those processes to finish, right? So that all of that can happen using things like Fast API and some of its other counterparts like Uvicorn and Starlet, things like that. So those are just some primers into that world of asynchronous programming. And so what this is telling you is that if you have an asynchronous client, then you can actually do all these operations independently of each other, right? So you don't have to wait for something to happen before you can add text. Like let's say you're already processing a user's request and maybe the request is giving the user an answer to something, but at the same time you're also storing these texts as part of the database. Like that could be a use case for where you might want to do something asynchronously.
cool, thanks.
Yeah, these are all very good questions. All right, so coming back to the client here. So this is where we now have the ability to add text, and you can also mention like some metadata that's associated with it and also some IDs. So you can put all these things together. Um, and yeah, so that's basically how we add text. And the idea is that it will basically give you a list of IDs that are associated with your added text. So we can create like unique IDs for our chunks, and those chunks would then be added to this thing called a collection. So if you remember a little bit about MongoDB in the past, we used to use this term called collection, right? Where a collection can have a bunch of different objects inside of it. So the same thing is true with ChromaDB, where with Chroma, you actually have a collection which contains all of your embeddings. So the object would give you things like an ID to refer to the object. You have the actual text of the object, and you have some metadata that's associated with it as well. So you might store things like, which document did this come from? Or which page in the document did this text come from? And then another thing that you might also add is, let's say you're interested in finding out the actual embedding, right? Like the embedding that's stored for it. So all of those things can be passed as part of that collection. So that's really where that's coming from. So whenever you work with something like this, you need to supply all three of these things. Although you don't necessarily have to mention the metadata per se, but definitely the text and the ID is necessary. Well, actually, no, the ID is optional too. So actually, it's just only the text, only, and then it will automatically generate IDs if you don't already have IDs. Yeah, so that, sorry, I forgot to mention that. So it will be assigned like unique IDs by using UUIDs. So basically, the only thing you need to add is the text, right? So that's what we're going to get from our other file, which is the text chunks. So we're just going to go over here and just mention from our custom modules, right? We're going to say from text chunks, we're actually going to get those results. And we're just going to get the ones that come from our split result from the recursive text splitter. So let's say you do that. We can say split result, right? And now from here, the idea is that when you go into the add text, you can now say that the texts are your split result, right? So this is going to give you all of those. So now we're adding not only the chunks, but also the embeddings to a default ChromaDB collection. So that's what's pretty cool about this, because you're mentioning beforehand that the embedding function that you're using is the nomic embed text that comes from Llama embeddings. So all of that is actually coming from here, right? So that's going to actually help you a lot to be able to get the embeddings along with all the information. So it's a nice software development kit, right? Where you can get all of this power packed into just a few methods, right? So it's really helpful. So now that we have all this, the next thing we want to do is you want to perform some kind of a query search, right? So you can actually perform like a search query by doing chroma object dot and search. And then when you do search, it's going to ask you for the query. And then in the search type, you can mention different metrics. Remember I told you before, there's one called like MMR, and then there's like similarity or similarity score threshold, right? So similarity score threshold is a bit more specific, like where you only want to return results based on a certain threshold. But similarity is also pretty good too, because like it's the it's the most flexible one. And you could just say that, yeah, I just want like the top, like 3 results or something, and it will just like base it off of that. Um, and I'm sure that you also have the ability to ask for more results. So if you do, let's say, for example, let's see, search, I think it's actually what do you call that? Like a keyword argument. Yeah, let me check that real quick. So Langchain Chroma search. Pretty sure it's actually a keyword, but I'm just going to double check that for you. Yeah, so yeah, so you could do, okay, you could also do a similarity search directly. So I think if you just say like similarity search, yeah, so if you do that, then on here you can mention like what the results are. So you mentioned the query, and then in the K, you can just mention like how many search results you want. And you can also you can filter by metadata as well. So let's say if you had like 5 different documents, you could actually say in the filter that if there's a key that's like associated with your metadata, you could say to only get it from that particular document. So you can also add this kind of functionality to help you with your similarity search. But for now, let's say you just go with the basic one, then it will take your query as a string, and then it's going to make it go through nomic embed text to give you an embedding that's associated with your query. And then what it's going to do is it's going to now do a search result by looking at a similarity, cosine similarity with the rest of the chunks that you have inside the vector database. And then from there, it's going to try to find, based on your value of k, the top results. So if you set k to 3, then it's going to give you like the top 3 chunks that have the most semantic similarity with your query. So that's essentially like what it does, right? So if you set the query, oops, sorry, if you set the query to, let's say, what did the president, say about Kennedy Jackson? So this could be your query. And then let's say you set K to, let's say, 3, right? If you set K to 3, then this is going to give you a result, which is now a list of documents. So now you can call this as results. And then from here, let's say if K is 3, you should expect to see 3 different results here, right? So we can now print the length of results, and we should be able to see 3 different results. So let's actually try this out, and let's just verify that this is all working. So let's go ahead and run it. Okay, so it's saying failed to send telemetry event client start, but you can see it did give you 3. So it actually did give you 3 results. So now from there, what you want to do is you want to actually see those results, right? So now let's look at the first, maybe like the first chunk, right, that you get from this. So if you were to do, let's say, print results 0, but remember one of the things it says is that it gives you a list of documents. So if you want the text, you have to change this to page content, right? So then you actually get the string. Okay, so now if you run this again, it should give you 3 still. And then afterwards, it says, and I did that 4 days ago when I nominated Circuit Court of Appeals Judge Ketanji Brown Jackson. Not bad, right? We actually said in the query, what did the president say about Ketanji Jackson? It actually gave you a part of the text which mentions Ketanji Brown Jackson. So that's it was able to do that by just doing that embedding search. Now, of course, if you made these chunks even longer, right? If you made instead of 100, maybe if you made it like, let's say 200 or 300, then it's possible you would get much more context than just starting it with and. But it still gave you a pretty decent result. And it also thinks that there's 2 other areas like where it has some information, right? So we can even try to print those too, right? So you could easily just like create a loop, right? And loop through all the different resulting chunks, right? So you could say for chunk and results, you could say to print the chunk.page content, right? And then you could also tell it to do a new line, right? So let's say if you do that, then you can see what they are. Yeah, let's see. There you go. So it says, and I did that 4 days ago when I nominated Circuit Court of Appeals Judge Kennedy Brown Jackson. And then we can see Brown Jackson, one of the nation's top legal minds, who continue Justin Breyer's legacy of. And then one of the most serious constitutional responsibilities the president has is nominating someone to. So as you can see, like because we set like the character limit to like 100, that's probably why when you're using it recursively, it's not giving you the full context. So if you increase that size to something larger, then you'll get much more context here. But these are some of the things to keep in mind, right? That even when you work with these text splitters, they're not magic, right? Like you have to experiment with their parameters to get the perfectly chunked text that you want. So this is why the chunking matters a lot, right? Whenever you work with a RAG system. But ideally, what you would expect is that once you get the answer to this, so let's say you have the query, you have the embedding, and all this is done, then the next thing you would do is you can pass one of these chunks as an input to an LLM, right? So now you can say you're using like Llama 3.1, or you can use, let's say, Gemma. And from one of those models, you can now tell it to do something with this output. So you could say, like summarize this output or give me like the main points of this output. So that's really where, it becomes what we call as a retrieval augmented generation. Because the reason why they call it is retrieval augmented is because this is the context that you're getting, which is relevant to the question that you're asking. So that's what we call is retrieval augmentation. So that's really what that means. And so after getting that relevant text, now what you want to do is you use that text as part of your prompt, right? That you use for all your LLM stuff to be able to get a more context-aware output, right? Where it's using that context that you're supplying to be able to help you get an even better answer, depending on what you're trying to achieve with your LLM. So in a nutshell, that's really what it's doing. So does that make sense? Any questions about that process?
Is this scenario relevant to the audio matching that I'm trying to do?
Absolutely. So the way that it would change is that instead of having a text query, you would be having an audio query. And what happens is that in your vector database, you can embed any kind of data, right? You can embed text, images, video, audio, you name it, right? Now, of course, with audio, it's interesting because it all depends on how you're ultimately storing the embedding. There are some models that can just directly convert it. You'd have to use something called a codec to do that. But let's say if you want to translate it to something like an image, then you can turn your audio files into spectrograms, right? And then the spectrograms would then go into some what we call as an image encoder. So this could be something like a convolutional neural network. It could be like a vision transformer, right? A lot of different options for that. And the idea is that the output of that process is now going to be an embedding inside your vector database. So you would now get chunks, but now the chunks are actually going to be like your spectrograms. Or if you're doing the audio directly, then the chunks would be your audio files. Maybe you look at it in terms of albums, right? If you're doing music. And then with music, you could say that all of your different songs are now what you see inside of your chunks, right? And now the idea is that you have metadata saying, hey, this is the artist, this is the album, and all that stuff, right? So it's still pretty relevant. And then in the query, what you're doing is you're saying that the query could be like a song, maybe an MP3 file, maybe it could be like a spectrogram that's related to an MP3 file. And when you're passing it in, you're telling it to do that vector search, right? So it's going to find out if you set K to 3, it's going to give you the top 3, let's say, audio or spectrogram results that are related to your input MP3 or spectrogram. And then from there, you can now use that output that you get. And let's say you have like a multimodal LLM, right? Something that understands maybe image and text. You can now pass in that image as part of your LLM and tell it to do something with it, saying, hey, here's a recommended song that I have. So from this recommendation, give me the pitch or, whatever, right? So you can give it more things to do from an instructional basis. But in terms of what you would consider, let's say, from a fingerprinting perspective, vector search can definitely be used for fingerprinting, like even with just the vector search.
Awesome. Yeah, I can see that. Cool.
Yeah. Of course, there are some other moving pieces to it, right? Because it's a system where you have to figure out how you're going to embed those other types of data. And so that's really where, there's a lot of R&D that's happening in the field, right? Like people are taking different approaches to it. Some people will take the source data as it is. Some people will convert it to another format and then embed it, right? So there's a whole plethora of ways of doing this, right? Now, is there one way that's better than the other? Kind of depends, right? It depends on like the scale of your operation. If you're thinking like Shazam style, or let's say maybe Google Music or Apple Music sort of scale, then probably you want to be careful with how many embeddings you have, right? Because you're going to have a lot anyway, right? Just with your catalog. So that's where you might start to think a little bit more about which encoders make more sense, right? For being able to embed that kind of data. But yeah, but that's what makes this field interesting, right? Like there's no like perfect one way to do the whole thing. Like it's trial and error, and you just have to see what works based on the constraints you have. Cool. All right. So I think that's a lot. I think we really covered a lot today. Of course, the last part of this is once you have one of these outputs, you can then feed this as part of a prompt to, let's say, Langchain Olama for the chat Olama, right? That's where you would add that last part. I purposefully didn't add that as part of the workflow because I want that to be the homework assignment. Like I want you to look at the scripts that we have, play around with the chunks, and try to see if you can get an even better search result than what we have here. Maybe you can reduce it so then it gives you one chunk that has everything about Kevin G. Jackson, and then try to see if you can get the chat Olama to summarize maybe in 3 bullet points, like what the president actually said about Kevin G. Jackson. I think that could be a pretty good homework assignment just to get you to play around with these concepts. And then next week, we're going to move into some of the more advanced stuff about RAG. And that's also around the same time when I'm going to release the new portions of the AI course, in which we also talk about those advanced things. So it's going to be pretty cool. You know, it's going to be a lot of fun content. All right. So I got to go in a few minutes, but are there any questions I can answer before I go?
I got a quick question about what kind of MacBook Pro you have.
Oh, yeah. So I'm using a I believe this is a 2023, but it's an M3 chip. It's an M3 Max chip. That's what I have for Apple Silicon.
How much RAM you have?
This one I believe is 48. Let me check.
48. Oh my God.
Yeah, it's 48.
All right. So I'm currently using, the reason I'm asking, I'm currently using a MacBook Air. Right now I have 24 gig. Um, I'm thinking about upgrading to MacBook Pro. You think it's going to helpful or just MacBook Air is good enough?
I mean, MacBook Pro definitely gives you a lot of advancements on the RAM for sure. So that does have its benefits, right? Especially with the fact that if you're doing a lot of stuff in programming, that involves like processes on your computer, especially if it's like very like graphics intensive, the unified memory that you get is really good on the MacBook Pro. So it's worth it. Like it's definitely worth the switch.
Air also, MacBook Air also has unified memory, same thing.
It does, but it also has less RAM, right? So
Yeah, less RAM, but you can get the same RAM too, right? So I could get the same 48 if I want to configure it to be 48. I think so. Yeah. But
okay, well, yeah. Then it's interesting, because then if that's the case, then it shouldn't really make a huge difference.
because only thing you're getting additional is more GPU core and CPU core with the Pro, and plus you get all those other fancy things like more USB-C and all those things, right? But
Yeah, that's true. But what I was trying to point out is that, you know, having more compute, especially in terms of the cores, actually those are all very useful. Like
okay.
especially when it comes to anything that has to do with the GPU, and also like for handling multiple processes. But it also depends a lot on what you plan to do with it, because a lot of these things you can also train on the cloud as well, but you would just have to pay for all the cloud compute that you're using.
Right, that's become very expensive very quickly.
Okay, so that's the project breakdown. I hope you enjoyed. And if you are interested in learning more projects just like this, so you can learn a bunch of tools and walk through a bunch of real life projects so that you can put on your resume and so that you can feel confident talking about these on the interview, then click on the link below and see how you can work directly with me and my team at Data Engineer Academy, because we've already helped over 2,000 people just like you. And all you have to do is click on the link, book a call, see what we have to offer. And if you don't want to work with us, all good, no worries at all. But if you do, click on the link below and let's see how we can help. Cheers.